Welcome back to the channel. In the previous video I showed the complete build process of this BGA Rework Station. In this part I will calibrate the upper and bottom temperature controller and also setting up the rework profile to remove a GPU from a graphics card. The affiliate links to the products I used to build this BGA Rework Station can be found in the video description. By using these links to shop, you are directly supporting this channel at no extra cost to you. If you like my content, please give a thumbs up and subscribe to my channel to help this channel grow. So, let's start. This is the REX-C100. This is a temperature control that is used for heating up the bottom plate. On the left you can see the indication LEDs. Two LEDs are the alarm indications, alarm 1 and 2. Let's say you have set the set point value on 180 degrees and the temperature controller overshoots it by 10 degrees. It can activate a alarm 1 and 2. So you can connect a buzzer on the output, a light, anything you want. When output 1 is turned on, it will drive the solid state relay and that will turn on the bottom plate. Then we have the Autotune LED. In order to calibrate this controller, you have to run the auto-tuning functionality. And when this functionality is turned on, it will blink this LED. When it starts blinking, it will auto-tune the configuration parameters of this controller. And once the auto-tuning is done, this LED will be turned off. Auto-tuning is a function that automatically adjusts the controller's tuning parameters to optimize its performance or process. This tuning process involves adjusting the PID parameters in the settings to achieve the desired control performance, such as minimizing the overshoot, reducing the settling time, and maintaining the temperature stability. This auto-tuning functionality automates this tuning process, so you don't have to do it manually. And it does that by testing the system's response to different control parameters and determining the optimal values for those parameters based on the observed behavior. So it will measure the temperature and the time that it takes to heat a bottom plate to the desired set point temperature. On the top side is the processed value, also known as the measured value. So the temperature that is measured by the thermocouple will be displayed on the top side of this LCD display. The display below will show the set value or the set point value. The set point value represents the desired target temperature that the controller is programmed to maintain within the controlled system. So if you want to heat the bottom plate to 180 degrees, you will dial in 180 degrees on the bottom display, and on the top display you will see what the current temperature is. And when the bottom plate starts heating up, you will see the increase in the measured temperature on the top side. When you press the set button, you can go to the different settings and adjust those settings, and you can also set the set point value, so the target temperature. When you press the left button, then you can jump to the different digits. So let's say if you want to change the value on digit number 3, you will press the left arrow and then it will jump to the next digit. Then we have the down and the up button. With these buttons you can adjust the value of this set value. This is the front panel for the PC410. This is the temperature controller for the infrared top heater. The first display is the processed value display. In the processed value display, you can see the processed value or the temperature value of the thermocouple. So the current temperature will be shown here. And in the set value, you can set the target temperature. You can also see the time, the measured value and the set value, depending on this button here. So if you press this button, you can select time, measured value or the set value to be shown in this display. In this display here is a pattern number. So in pattern number you can set different steps of temperature profiles for one specific program. Let's say pattern 1 is a temperature profile for removing a BGA that has leaded solder balls. And in pattern 2 you can make a profile for BGAs with a unleaded solder balls. So you can run different programs and each program is known as a pattern number. When you choose pattern 1, and you press the run button, the program will be started. And the run indicator is lit and it indicates that the program is running. These LEDs here will give you an indication what the program is doing. If the temperature is rising, this LED will start, and when the temperature is held constant, then this LED indicator will be turned on, and when the temperature is cooling down, this LED will be lit. And in this display indicates in which step the program is currently running on. So you can have different steps within the pattern. And if you are in step 1, you will see that the step 1 is activated. And if you go to step 2, then step 2 will be activated here. When you press the display select button, you can set the display of the set value to show the value of the time, the measured value, or the set value. And it will be displayed here. With the set program, you can change the settings for this pattern. With the up and down button, you can change the value of the parameters. This auto manual operation, I will not use it, so I will not explain this one because I don't use it. The parameter settings key, you can set the parameters of the different settings. I will not use the run program button, so I will not explain this one. When you press this pattern button, it will select the program pattern number. So if you want to run program 2, you have to press the pattern button to select the correct program. When output 1 is lit, it means that the output for the solid state relay that drives the top heater will be turned on. When the output 2 indicator is lit, it means that the solid state relay that drives the bottom heater is turned on. If you want to go to the settings, press the parameter settings key for 3 seconds, and then you will go to the settings menu. And when you press this parameter settings key once, then you can go to the different settings within the settings menu. By pressing on the up and down key, you can adjust the value for each setting. Let's say you want to change the values of the steps within the pattern. Then first you have to select the correct pattern by pressing this key. Then you have to choose the program parameter. You will see in the upper display the display parameter name, and in the set value display you can see the value. By pressing the up and down button, you can change this value. Before starting the auto-tuning process, we first have to set the target temperature, and we will set it on 180 degrees. So we will set the bottom temperature, and we can do that by pressing the set button one time. And by pressing the up and down key, we can change the target temperature in this set value display. Set the bottom temperature to 180 degrees. And to go back to the main screen, press the set button one time. To start the auto-tuning process, we have to go to the auto-tuning settings. And we can go to the settings menu by long pressing the set button. Keep this set button pressed. And after that, press the set button one time, and then you can scroll to all the settings. If you have found the auto-tuning settings, you will see ARU displayed on the top side, and the value is displayed on the bottom side. And if I'm correct, it will be shown 000, and by pressing the up key, it will set this 0 to 1, and the 1 indicates that the auto-tuning setting is turned on. Press one time on the set button to go back to the main screen. At this point, the auto-tuning LED will start blinking, indicating that the auto-tuning process is started. This auto-tuning process can take 15 to 15 minutes, so you have to wait until this auto-tuning LED is turned off. When the auto-tuning is done, then the parameters PID will be set into the settings. Also be careful, because when the auto-tuning process starts, it will heat up the bottom plate to 180 degrees. So do not touch the bottom plate. To start the self-tuning process, press this key and hold it for 3 seconds. And then short press this key to scroll to the parameter tune. So on the upper display you will see tune. And by changing the value to on, it will start the self-tuning process. Then you have to press this key to scroll through the settings menu, and eventually you will get out of this settings screen. Next, output 1 will be activated, so this LED will be turned on and also the output, and it will turn the top heater on, and it will heat the top heater to 180 degrees. On the set value display, you will see the text tune. You will see the text blinking, and this means the auto-tuning process is in progress. On the process value display, you will see the current temperature, and it will rise until it reaches the 180 degrees that you have set in the set value. When the auto tuning process is done, this text tune will not be displayed anymore, and the output 1 indicator will be turned off, and at this point the self-tuning process is done. For the PC410, we will do a zero calibration. By doing a zero calibration, there will be no difference between the measured temperature and the set temperature that is set in the controller. When the calibrating process is successful, this temperature controller can measure the temperature very accurate. The same goes for the REX-C100. We have to calibrate this temperature controller so that there is no difference between the measured temperature and the set temperature. For both the controllers, I will use the ice point calibration. And step 1 is to prepare a ice bath. So start by preparing a stable ice bath. Fill a container with crushed ice or ice cubes and add just enough water to cover the ice. Stir this mixture to ensure a uniform temperature throughout. Let the ice bath stabilize for a few minutes and then measure the temperatures. For step 2, we have to verify the ice point. So we use a calibrated thermometer to measure the temperature of this ice bath. So when the ice is melting, or almost all the ice is melted, it should read very close to 0 degrees or 32 Fahrenheit. The accuracy of this reference thermometer is crucial, as any error in its measurement will propagate in the calibration process. In step 3, we will immerse the two thermocouple sensors, one for the top heater and one for the bottom heater. Both will go into this ice bath. Also, the reference thermometer will be immersed in this ice bath. Ensure that the sensor is fully submerged and surrounded by the ice-water mixture. So in step 4, we have to adjust the calibration of the top temperature controller and the bottom temperature controller. The bottom thermocouple and the top thermocouple will give a temperature reading on the top side. And if it deviates from the 0 degrees from the reference thermometer, then you have to calibrate the temperature controller. For the REX-C100, long press this set button to go to the settings menu. If you press the set button one time, you can scroll through the settings. And we have to go to the setting SC, which stands for sensor correction. If the thermocouple reading deviates from the expected 0 degrees from the reference thermometer, you will see the deviated temperature here. When pressing the down or up button, you can put the offset into this setting. In the case there are 0 degrees on the reference thermometer and the displayed temperature is plus 8 degrees, then you have to press the down button 8 times. So if you want to get out of the settings menu, keep the set button pressed. If you want to set the temperature offset of this PC410 top heater, press this key and hold it for 3 seconds. If you are in the settings menu, then you have to press this button again until you go to this offset parameter. This parameter will be shown in the upper LED screen. Then you can adjust the offset temperature by pressing the up and down key. Next we will set up two temperature profiles. So profile 0 is needed to run the Autotune process for the REX-C100, and the pattern 1 will be used to remove a GPU from a graphics card. So in the next demo you will see that I will create a pattern 0. Everything with 1 is step 1 and this is step 2. So in step 1 we're gonna increase the temperature with 1 degrees every second until we reach 0 degrees, and then it will dwell for 888 seconds, and then this program will end. The reason for this profile is to activate the output 2, because output 2 will drive the bottom heater and we need this output to be on to run the auto tune process for this REX-C100. Eventually it will run a program, output 2 will be activated, and this program will run for 888 seconds. In the PC410 we have to set a temperature profile, and we set the profile on different parameters. So we have a R parameter, a D parameter and an L parameter. So the R parameter stands for a ramp. A ramp consists of a slope and a 1 degree increase per second. So you can dial the different options that you want. But in our case we will rise the temperature at 1 degree per second until we reach some kind of set temperature. So every second this temperature will rise until it reaches this target set point. And L, that stands for the target set point. And from here it will wait, that's why we call it a dwell. It will wait an X amount of seconds before proceeding to the next target temperature. So this is step 1 in the temperature profile. This is step 2 in this temperature profile. And eventually we want to go to a reflow state. And that's why we need to program this temperature profile to get to that point. In this program we have 4 phases: the preheat phase, the soak phase, and the reflow phase. And then we have the cooling phase. So in the preheat phase, we want to raise the temperature of the PCB board to 180 degrees. And when we hit 180 degrees, then we will ramp up to almost 230 degrees. And that is the moment where the solder balls of the BGA will melt. And then you can reflow it or remove the BGA. So in this phase, we can remove the BGA because the solder is melted. Now we will set up pattern 1. To set up pattern 1, what we want is that the temperature for the bottom heater, to raise the temperature up to 185 degrees. And on the top of the PCB board, we want to measure 140 degrees. So when the top temperature reaches this 140 degrees, we want to start step 2 of the pattern 1. So from step 2, we will increase the top heating temperature to almost 230 degrees. To try to remove the GPU from the graphics card. Bottom heater will reach 185 degrees within 480 seconds. That is what I timed. So I dial this in the settings in the program. After that, the step 2 will start of this pattern. For removing a GPU from a graphics card, I create a pattern 1. It consists of 1, 2, 3, 4, 5, 6, 7, 8 steps. So step 1 and step 2 is the preheating phase. The preheating phase will gradually raise the temperature of the entire PCB board and component to a level below the melting point of the solder, and this step helps minimize the thermal shock and ensures uniform heating throughout the board. So all the ramp rates are 1 degrees per second. So in step 1 it will raise the temperature at 1 degrees per second until it reaches 0 degrees. And from there it will wait 480 seconds. In this time frame the top heater will be off, but the bottom heater is heating the PCB board up to 185 degrees. In step 2 we want to raise the temperature 1 degree per second until it reaches the target temperature of 190 degrees. When it reaches the 190 degrees we want to wait 66 seconds, and from there the step 3 starts. And this zone is called a soak zone. In this phase, the temperature is increased to a level where the solder begins to melt and flow, but the BGA is not yet reflowed. The board is held at this temperature for a specified duration to allow the solder to reach its melting temperature and achieve proper flux wetting on the solder balls. So that is what the soaking phase does. And we will raise the temperature up to step 4. So at step 3, that's here, we will raise the temperature at 1 degree per second until it reaches 200 degrees. From there we wait 64 seconds. From here we will start raising the temperature at 1 degree per second until it reaches 210 degrees. And from here we will wait 32 seconds. And we're now reaching the reflow zone. During the reflow phase, the solder transitions from a solid to a liquid state. Is the reflow zone for the leaded solder balls, and in this zone for lead-free solder. Lead-free needs higher temperatures to melt the solder balls. It's also a danger zone because the temperatures are getting really high and you have to monitor it really precise. So in step 5 we will raise the temperature 1 degree per second until we reach 220 degrees. We will wait 35 seconds. And from there we will raise the temperature at 1 degree per second until it reaches 235 degrees. In this region you can do a BGA nudge test to see if the BGA is moving. And if yes, then you can remove the BGA or your reflow process is done. And then you can turn off the rework station. If the BGA is not moving, we will proceed. So at this point the temperature is 235 degrees. It will stay in this region for 200 seconds, and then step 7 will be started. It will raise the temperature at 1 degree per second until it reaches 240 degrees. It will wait for 40 seconds, and then the last step will be activated. It will raise the temperature at 1 degrees per second until it reaches 255 degrees. It will wait for 40 seconds. After that, the programs will automatically stop and the temperature will go down. It's important to note, when you do the BGA nudge test, that's the moment that you want to remove the BGA from the PCB board and turn off the rework station. You don't want to proceed any longer in this region because the temperatures will get higher and higher, and that can damage the components. In some cases, a CPU removal takes a lot of heat, so you need this profile to guarantee that the whole CPU is heated to the correct melting temperature, and then you can remove it. So the profile 1 that we use is used to remove and refill BGA with leaded and unleaded solder. And also, there is no specific reflow pattern for the Xbox, for the PlayStation 5, for the Nintendo Switch. It all comes down to temperature measurements and time. So when you measure the PCB board, then you know what is happening. And eventually, when you are in this region, the solder will melt and then you can remove the BGA from the PCB board. So in the next videos, everything that I explained will be shown. We will make pattern 0 and also pattern 1. And after that, you will see the demo about how to remove the GPU from the graphics card. So if you like this video, please give it a thumbs up and subscribe to this channel to help this channel grow. Thank you very much for watching. Till next time, bye bye.